Okay. Okay, so as I was saying, this Friday morning is the deadline. If anybody wants to retake the right triangle trig quiz from last week, you just have to have the assignment for right triangle trig turned in before you go ahead and retake. Speaking of homework, we're going to go ahead and start after the announcements with the angles and their measures assignment. We'll talk about any questions you might have. There's a quiz over that tomorrow. So it doesn't cover the unit circle, just angles and their measures. Now, looking at next week, hopefully this is already on your calendar, you're thinking about it. Next Thursday, September 4th, this is the first exam of the 9 weeks. Okay, so you do want to be looking at that. It's not too early to go ahead and start taking maybe 5-10 minutes a night, just looking over your material. Okay.
Pretty sure we have a meeting next Thursday. I
Mhm.
don't know if it's away or here.
Okay.
If it's away,
Then I'll have you just take it Friday when you're here. So we'll get it taken care of. It's going to cover right triangle trig. It's going to cover angles and their measures. Also the unit circle, evaluating trig functions on the unit circle. Basically everything up to that point. And remember on Friday, I'm going to be passing out 3x5 note cards. You can go ahead and write whatever you'd like on the front and back that you think is going to help you out. Bless you. We got our first pep rally tomorrow during 8th period. I've been talking to folks about their contracts and logging on the College Board to join 4th period's AP pre-cal class. So does anybody have a contract for me? There we go. Thank you, thank you. Anybody else? Someone not? Hi. Okay. Any other contracts? Okay. And most likely on Friday, I'll be logging on to College Board again and seeing hopefully that some people have joined. If not, we'll go ahead and pull those folks aside on Friday, pull out Chromebooks, and we'll just go ahead and join right there. Let's see. So I've also had a lot of students asking me lately about the AP exam. Okay. I don't know if I mentioned this, but by the time you get to May, there's no formula chart or anything provided during the exam. So everything we do from August all the way to May, you've got to be able to, recall all that information. So what I've done for you, I went ahead and posted the course and exam description. So it is a kind of lengthy. It's 195 pages long, but it basically can answer any question you have about the AP pre-cal exam. What I would suggest is going to be really useful for you right now is going to page 153, because this is a breakdown. Okay, so you're going to have 28 multiple choice questions with no calculator, 12 multiple choice questions with a calculator, and then you're going to have 4 free response questions, 2 with a calculator, 2 without a calculator. Now, there's a lot going on with the free response. We're going to talk about that in a lot of detail, but that's going to wait until the second semester when we're closer to the actual exam. But I mean, if you just keep on going, you can go ahead and see what the weights are going to be for some of these. Okay. As we go through our different concepts here, I need a new mouse. Okay. Now, also, because yesterday we started the unit circle, I went ahead and provided you a digital copy of this. Okay. So this table uses all of those angles from the unit circle that we had yesterday, and it shows all 6 trig functions evaluated in all of those. Okay, so this could come in very, very handy for some folks. Okay, all right, so a lot of information, but do we have any questions? Were you gone yesterday? Okay, get that for you. There you go. All right, any other questions? Here, whoa. Yeah, it's okay. Okay, all right, so let's take a look. Okay, so here is the assignment for angles and their measures. This is what the quiz tomorrow is going to cover. So, what questions do we have? All of them. Number 26. Okay, let's take a look. Okay, so we got ourselves a diagram. We want to find the measure of theta, both in radians and degrees. Okay, so think back to geometry. We've got these little arcs to represent the angle measures, but what are those tick marks telling us? Yeah, they're telling me all three of those angles are congruent. Now remember, what's the measure of a quadrant? Okay, that's 90 degrees. So that means that each of these here would be 30 degrees. Okay. Now what we're wanting is theta that starts in standard position and it rotates all the way around to that first of three angles. Okay, so I'm looking for a 180 plus 30. What do we have? 210. Okay, so theta is 210 degrees. Okay. Now this is one of the angles that are coming off the unit circle, so you may or may not recognize it, but even if you don't, let's go ahead and convert it. So I'm going to take 210 degrees over 1. What was the conversion to make that radians? Pi over 180. There we go. Pi over 180. Okay, first thing we're going to notice, okay, those degrees are going to cancel. Okay. And I need to go ahead and simplify this. What's the largest factor that'll divide 180 and 210? It is 30. Okay. So how many times, what's 210 divided by 30? Okay, 7. 180 divided by 30. Okay, that's going to be 6. And remember, they're also both divisible by 5. They're divisible by 10. So if you need to do this in several steps, I mean, that's fine. There's nothing wrong with that. Sure. Could be, yes. Well, for the angles on the unit circle specifically, yes. Yes. Mm-hmm. That's exactly right. So we also have 7 pi over 6 radians. Okay. All right. Oliver, is that good, sir? Okay. What else? Yes. 4. Okay, 4, 4, 4. Okay, so I believe we're sketching an angle. Okay. So not only do we want to sketch the angle, but then we want to state its reference angle. Okay, so number 4, we got a radian, 23 pi over 4. Okay, so let's go ahead and fill in my plane here. So it's positive. We know we're going to go ahead and rotate counterclockwise. So we're going to start with 0 radians. And let's go ahead and review those locations. What was a quarter of a revolution? Pi over 2, 1 quadrant. Half a rotation? Pi. 3/4? Pi over 2. And then all the way back around, 2 pi in 1 revolution. Okay. Now, if we had an improper fraction such as this, our strategy was to rewrite it as a mixed number. So what is 23/4? 5 3/4 pi, yes. So we're going to take care of this whole number first. Okay. So I'm going to go ahead and start here in standard position. Okay, so there is 1 pi. That's half a rotation. So there's 2 pi, 3 pi, 4 pi, all the way back around to 5 pi. Okay, so I've taken care of that. Now all I want to do is rotate an additional 3/4 pi. All right. So remember, we just said that 1 quadrant is 1/2 pi. So how does 3/4 compare to 1/2? Okay, 3/4 is larger, so this is going to be in quadrant 4. So coming all the way around here, probably looks something like that. Okay. Now, after the sketch, it did say we want the reference angle. Anybody remind me, what is the reference angle anyway? There we go. He's absolutely right. So it's created using the terminal side, okay, where we just stopped rotating, and the closest x-axis, in this case, it's going to be the positive. So there's a couple of different ways you could do this. I mean, look at the mixed number. You already rotated 3/4 pi, so to get 1 full pi, you got to rotate an additional pi over 4 radians. But let's say you didn't look at it that way. You want to do a little bit of algebra to kind of confirm it. Okay, so this closest x-axis, it's no longer 2 pi. See, we're very close to 6 pi radians because we rotated to 5 3/4. Okay, so I'm going to go ahead and take 6 pi, and I would subtract my 23 pi over 4. Okay, of course we need a common denominator. Okay, so that would be 24 pi over 4 minus 23 pi over 4, which still gives me the pi over 4 we're looking at. Alex, is that good? All right, what else? Pi over 4 is your, yes, so this angle right here, this angle, that's pi over 4 radians. That's my reference angle. So the answer is a combination of both the sketch and that angle. All right, anything else? Number 3. Okay. Okay, so we're going to do the same thing here. Now it's negative, so we're going to rotate clockwise. I'm still going to start with 0, but rotating clockwise, this first axis, that's negative pi over 2. Just let me draw that. Then we have a negative pi, negative 3 pi over 2, all the way around to negative 2. Okay, negative 2 pi. All right, so we've got a negative 1/6. Okay, how does a negative 1/6 compare to a negative 1/2? Okay, it is greater than, so yeah, it's going to be in quadrant 4. So let's say right here. Okay, so let's say this angle is pi over 6. And remember, again, we're not saying the angle is negative. The negative just tells me the direction that we're going to rotate, right? Okay. So if I go ahead and now take a look, the reference angle created using that terminal side and the closest x-axis, what is that? In this case, it is pi over 6. So do you remember I showed you, I believe it was last week, that an angle in quadrant 1 is its own reference angle? Well, what you're going to find here is that rotating clockwise and angle in quadrant 4, the opposite is its reference angle. Okay. All right. Oh yeah, you always connect it to the x-axis, not to the y, never to the y. All right, Lexi, is that good? Okay. What else? Uh-huh. Yeah, essentially. Now, in some cases, it depends. Like if you're in quadrant 3 and you're rotating counterclockwise, okay, then the x-axis is going to have a smaller value than your angle right here, but you'll still take the difference. It's just the reference angle is always positive no matter what. Okay. All right. Well, we have that quiz tomorrow over angles and their measures. Okay, shouldn't be too terrible, but if you want to hang on to your homework, kind of use that as a study guide along with your notes, I mean, you're more than welcome to go ahead and hang on to that. But is there anybody ready to turn it in? Okay, if you are ready to turn it in, make sure your name is on that. Pass it to the front. If you're hanging on to it, that is fine. That is your choice. Okay, and I want to keep an eye on the clock. We're out of here at 12:04. Okay, we still got plenty of time. Sure. Okay. Thank you. Okay. Any others? Okay. All right. Well, let's go ahead and put this to the side, and let's take a look at what we did yesterday. Okay, so I introduced you to the unit circle. So we broke this up into 3 more manageable parts. We talked about the degrees, the radians, and then the coordinates. So we're talking about the XY coordinate of each of these 16 locations. Okay, we went a little deeper here. Okay, we have several special right triangles showing up. So the 30-60-90 and the 45-45-90 have these exact measurements in the unit circle. And remember that each hypotenuse of one of these triangles, what is that to the circle? That's the radius. Yes, absolutely. Okay, good. So let's go ahead and do this. We kind of took the majority of our time yesterday to run through, but let's kind of just skip to the shortcut. Let's go ahead and completely fill in everything we know about quadrant 1. Okay, so I'm going to start here on the x-axis with 0 degrees, 0 radians. Okay, from the assignment, we know that 90 degrees is pi over 2 radians. Now, if I'm looking at the cluster of points in each quadrant, remember they were 15 degrees from each other, but 30 degrees from the closest axis. So if this one is 30 right here, what's that next one? 45, and then this one is 60. Okay. Now, you can go ahead and take each of those. You can go ahead and multiply them by pi over 180. Go ahead and convert that to a radian, but remember, that's going to take time. So somebody help me out. If it was a multiple of 45, I counted by something. Okay, what you got? We counted by fourths. So like, for example, 45 degrees, let me do this in a different color, that would be 1 pi over 4. Then the next multiple, 2 pi over 4.
4 pi over.
There you go. And as we go, some of these are going to simplify. 2/4 pi is pi over 2. Okay. So if it was a multiple of 45 degrees, remember we counted by fourths. Okay. What if it was a multiple of 30? We counted by 6. There we go. So this one, 30 degrees would be 1 pi over 6. 60 degrees would be 2 pi divided by 6. 1/3 pi. That's absolutely right. Okay. Now, the only thing we have remaining in quadrant 1 is the actual location for all those angles. Remember that the unit circle, all I've done is taken a circle with a radius of 1, and I've placed the center of the circle on the origin of an XY coordinate plane. That's what the unit circle is. Okay. Now, because it has a radius of 1, 2 of these are super easy to figure out. This location would be 1, 0. This one right here would be 0, 1. Okay. Now, in order to find the others, we spent a good amount of time using those special right triangles. Okay. Well, let me go ahead and set this up real quick. Now, we noticed a pattern yesterday for all of the sets of the 3 points in each of the quadrants. Every single value was divided by what? Divided by 2. Divide by 2, 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 divide by 2. Now, what you're going to do is you're going to go ahead and start counting, but you're going to go clockwise. You're going to start at the top, and you're going to take care of the x's first. So this goes 1, 2, 3, and then you're going to count in the opposite direction. 1, 2, 3. Okay. And then what do I want to do with the numerators? Take the square root. But the square root of 1 is 1, so we can skip that. There you go. Right there, you have all the information in quadrant 1. Seconds. Okay. Now, why is this useful? How could this help me figure out quadrant 2? Yeah, the unit circle is symmetric. So what that means is if I were to fold along, say, the y-axis, these points here, their images would give me exactly what I'm looking for. And then I could fold over the x-axis. The points in quadrant 2 could help me with quadrant 3, and I can get the entire unit circle in a very small amount of time. Okay, so this is what we did yesterday. Questions? Okay. Well, let's see what else we got here. Then we dove a little deeper. We now know that cosine of theta is x. Cosine is your x variable. Okay. Sine of theta equals y. Sine is your y variable. So any point on the circle, instead of x comma y, we can now write it as cosine comma sine. And there was also another major change. Up until now, the 3 parts of our right triangles, the hypotenuse, the opposite, and the adjacent, those are the names we've been using. They're now gone. We are only going to refer to the sides of a right triangle in terms of the variables. Okay, so the horizontal x, the vertical y, and then the radius r. But remember, the radius is the hypotenuse of these triangles. Okay. And then I believe we finished up with this yesterday. Is that right? Okay, so for the people who weren't here yesterday, I would absolutely have that copied on your paper. Okay, so I'll give you a few seconds to do that, and then we're ready to go ahead and get into our notes. Yeah, when Kagan gets back, he should be coming back pretty quick, hopefully. Twelve oh four. Okay. No. When Kagan gets back, I got Harrison, and then it'll be you. A few more seconds. Okay, so now what we want to do is start to evaluate trig functions. And I've mentioned this pretty much since the first week. When you evaluate a trig function, any of them, okay, you input an angle measure, doesn't matter if it's degrees or radians, and then your answer, your output is the ratio of two sides of a right triangle that angle belongs to. Remember, every trig function wanted two specific sides. Okay, so what we're going to go ahead and do now, we're going to use the unit circle to evaluate some of these. So we're not really going to be following the directions in a lot of these, just kind of follow along. For number one, we're going to go ahead and sketch the angle, but we don't have to do that because we've got a unit circle right in front of us. Okay. It says evaluate sine and cosine of 4 pi over 3. Okay, so I want sine of 4 pi over 3, and I want cosine of 4 pi over 3. Okay. So if I plug this specific angle into these two trig functions, what am I going to get in response? Okay, well, where is 4/3 pi? What quadrant? That's in quadrant 3. So if I were to go ahead and sketch it, I'd start here in standard position. I would rotate all the way around. Well, here, there's my terminal side. I would stop rotating right at 4/3 pi. But here's the thing. You're super interested in the ordered pair at that location. That's all that interests you. So at 4/3 pi, we got this one. We got a -1/2 and then a -√3 over 2. Well, remember, an ordered pair, it contains both an x and a y value. You're going to be using these now to evaluate the trig functions. Okay. Can anybody tell me in terms of the variables, what was sine's ratio? It was y divided by r. Okay, so this is just like we did a couple of weeks ago. All we're going to do is plug in my information. Okay, looking at this ordered pair, what's the value of y? Yeah, -√3 over 2. What's the radius, though? What's r? Why? Because what do we call this? Because we're on the unit circle where the radius is 1. Okay. And then what happens if I divide anything by 1? Okay. So sine of 4 pi over 3, that is -√3 over 2. There we go. Okay. Okay. And then now we're going to do the exact same thing for cosine of 4 pi over 3. What was cosine's ratio? X over r. Okay. So I'm looking at the ordered pair. X has a value of a -1/2. The radius is still 1. So cosine of 4 pi over 3 is a -1/2. That's all there is to it. Okay. If you have the unit circle right in front of you, it is the easiest thing in the world. You just take the information off of it. Oh, and you're in line? So we'll try to keep an eye on that. Okay. Any questions? Now, we can even check ourselves. Let's see how we did. Let's go ahead and actually go to the calculator. Let's plug in sine of 4/3 pi. You'll notice my calculator is in radians because that's what my angle is. So control divide, we got 4 pi. Oop, that's not what I want. Whoa, that's going weird. Okay, hang on. Escape. Let's go ahead and delete that. There we go. Now let's plug in the right one. So 4 pi over 3. Now, the calculator is telling me this is negative 0.866 and so forth, right? What answer did we just get? So we got a negative square root of 3 divided by 2. Okay, we'll take a look. Remember, the value you get in the calculator, that means something special. That means two sides of that right triangle have been divided. That's the result. Okay. So let's go ahead and try another one of these. Okay. So we're going to try number 2. So with the unit circle, I want you to evaluate sine and cosine of 3 pi over 4. So sine of 3 pi over 4 and cosine of 3 pi over 4. Okay. Think about what we did on that previous example. Okay. This appears to try it again. Let's see what happens. There you go. Okay. Okay, so let me go ahead and catch up. Where's 3/4 pi? Second quadrant. Okay, so I'm going to start in standard position. I'm going to rotate over. So here is my terminal side. So this time, this ordered pair right there, that is what I'm interested in, because that's at 3 pi over 4. So I've got my x value, I got my y value, and we know what the ratios are. Okay, y is square root of 2 over 2. The radius is still 1. So sine of 3 pi over 4 should be root 2 over 2. Okay, what's the x value at that location? Negative square root of 2 over 2. Radius is still 1. So there we go. That's all there is to it. If you have the unit circle right in front of you, this is the easiest thing you'll ever do in your life. Okay? Now, here's what we're going to do. If you have a unit circle on your desk, take it off. Okay. Because if you got the unit circle, that's easy. Now we're going to go ahead and do these without the unit circle. So we're not going to reproduce the whole thing. We're only going to reproduce those parts that we need. Okay. So if you take a look, numbers 3 to 8, they're your 6 trig functions, but we're evaluating all of them at pi over 6. Okay. So without the unit circle, we're going to have to draw a triangle ourselves. Okay. So that's the first step. Always start by sketching your angle. What quadrant is pi over 6 in? It's in the first. Okay. So I'm going to go ahead and rotate. Let's say that pi over 6 radians is going to look like this. Everybody would agree? That's step 1, if you're evaluating a trig function without a unit circle. Now, this terminal side that you just drew, it's going to become the hypotenuse of a right triangle. Okay? Use this right at the tip, create a right triangle with the closest x-axis. Okay? Just like we did yesterday. Now, anybody ever help me remember, what is pi over 6? That's 30 degrees. This is the 30, 60, 90 triangle from yesterday. Okay. So if this right here is 30, that means that this upper angle, it has to be pi over 3. It's got to be 60. Now, if in the beginning you want to go ahead and draw your figures with degrees, I'm okay with that. There's nothing wrong with that. In fact, I'll go ahead and plug these in. Pi over 6 is 30 degrees, and pi over 3, that's 60 degrees, if it makes it easier for you. But remember, at some point, you're really going to want to start to work with those radians, because the AP exam only does radians. Okay, no degrees. Well, here's where yesterday is going to come in super important. Okay. Remember, we know we're on the unit circle, so the hypotenuse, which is your radius, that's 1. Does anybody remember what was the side length across from 30? Across from 30. Remember, there were 2 fractional values. It was 1/2. Okay. What was across from 60? Square root of 3 over 2. See, that's what we're doing. We're identifying in what quadrant, what special right triangle it is. Now I've got all my information. Okay. I have an x value, I got a y value, and I have the radius. So the hard part of the problem is done. Now I just go back and substitute. Okay. Like, for example, sine of pi over 6. What's sine's ratio? Y over r. Okay, so I'm looking at my picture. What's the y value? 1/2. The radius is 1. So sine of pi over 6 is just 1/2. See, we don't need the unit circle to do that. We needed a part of it, just not the whole thing. Okay. Are there any questions on this? Is anybody having a hard time? Okay. Now, we're going to go ahead and kind of skip around. Let's do tangent. Tangent of pi over 6, because there's something I need to show you. Tangent of pi over 6. Okay. What's tangent's ratio? Y over x. Okay. Different trig function gives me a different ratio, but I'm still using the same picture. Okay. Remember, what's the y value? 1/2. So I'm going to plug that in. What's the x value? Square root of 3 over 2. Now, typically for these sine, cosine, they're going to be super easy. Tangent, cotangent, you're probably going to have to do a little bit of algebra. Here, we're dividing by a fraction. What's the rule? We're going to multiply by its reciprocal. So that means I'm going to take 1/2 times 2 over the square root of 3. So does anybody notice anything about that so far? Square root's on the bottom. We're going to have to take care of that. Is there anything else I can get rid of? The 2's will cancel. Okay. So I've got tangent of pi over 6 as 1 over square root of 3. Okay. But Mariana's absolutely right. We still got to deal with that radical. So I'm going to multiply by square root of 3 over square root of 3. What's tangent of pi over 6? Any questions? Okay. Let's do one more of these together. Take a look at number 6, cosecant of pi over 6. That's weird. Yeah, I saw you create one before you leave, and now it's gone. Technology. Okay. Noble was next. Were you going to ask? Yes, so you'll be after Noble. Okay. All right, let's take a look at number 6. Cosecant of pi over 6. Can anybody tell me cosecant's ratio? That was r over y. Okay. Well, what's the radius? 1. What's the y value? 1/2. Okay. So multiply by the reciprocal. What's 1 divided by 1/2? Oh, now 1/2. Not 1.5. Let's go ahead and take that 1 up top times the reciprocal. So 2. And in fact, we didn't even need to use the trig ratio. Okay, what's the relationship between sine and cosecant? Remember, they're reciprocals, right? So if I'm evaluating both at the same angle, and I got sine to be 1/2, well, yeah, it makes sense that cosecant would have to be 2. Okay. Yeah, you just flip it. Okay. Now, here's what I want you to do. I'm going to give you a couple of minutes. I want you to now try 4, 7, and 8. These are all pi over 6, so these are all using that same angle. Okay. So find me cosine of pi over 6, secant of pi over 6, and cotangent of pi over 6. Gotcha. There are mathematical proofs. There are. Oh, I know. Yeah. At some point, throughout history, the mathematical community would come together and say, this is, the information we have. This is how we're going to present it. Yeah. Yeah. Kind of makes sense. Yep. Okay, so I even gave you the ratios in case you didn't recall those. But these new ratios, we definitely need to be as familiar with those as possible. Those I would probably say go ahead and memorize. Okay, unit circle, not so much. Is there anybody in here who's going to memorize the unit circle? Okay. So every year, there's some people who do it. So cool. Okay, let's go ahead and run through these. Show of hands. Okay. Carolina, you think you got number 4? Oh, you don't have to come up. Just go ahead and tell me what you got. For number 4?
For number 8.
Oh, for number 8. Yes. That's absolutely correct.
For number 4, I got square root of 3 over 2.
Yes.
And for number 7, I got 2 over 3. Square root of 3, I got.
2 over 3 times square root of 3? Yes. Perfect. That is exactly what we should be getting on those. Okay. How many people got all 3 of those right? Okay. Well, is there one that we want to take a look at? Yeah, Oliver. Which one? Let's look at 7. Okay. So we have this ratio R divided by X, right? Okay. So what's R? 1. Okay. So I'm going to go ahead and fill that in. I'm looking at my picture here. X is the square root of 3 over 2. So square root of 3 divided by 2. Again, we're dividing by a fraction. So I'm going to multiply by the reciprocal. So this is going to be 1 times 2 over square root of 3. But basically, times 1, I don't have to worry about that. What's the problem with this? We got a radical in the denominator, so we've got to rationalize that. So I'm going to multiply by square root of 3 over square root of 3. And when I do, that is where we get that one. Yes, sir. Let's do number 8. Okay. So number 8, cotangent has a ratio of x over y. So I'm going to go ahead and take the x, which is square root of 3 over 2. We got the y value. Oh, thank you. 1/2. You're going to see this a lot. Okay, we are dividing by the fraction, so we're multiplying by the reciprocal. Okay. And that's going to be a square root of 3 over 2 times 2 over 1. But what do you notice? Okay, 2's cancel. Why don't we rationalize? Because the radical is not in the what? It's not in the denominator, so we leave it be. Okay. All right. So here's what I want you to do, because we're almost out of time. If you take a look at numbers 9 through 14.
Sorry.
Oh, it is. Now, I'm not saying you have to evaluate 9 through 14. If you're feeling ambitious, go for it. All I want you to do on in preparation for these next 6, you'll notice every single one of them is evaluated at 5 pi over 4. Okay? I want you to go ahead, locate 5 pi over 4, what quadrant, draw the triangle that would correspond to that, just like we did here for pi over 6. Okay? That's where we'll pick up tomorrow after the quiz. All right. How are we doing? Okay. So what are we thinking about trig so far? It's not terrible? It's super fun? Okay, I heard Survey say yes. Now he's being super quiet. Okay. All right. So we're going to go ahead and stop there.